In today's lesson, we'll be learning how to factor quadratic expressions of the form ax squared plus bx plus c. This might look identical to the previous lesson, but it is not. The coefficients of a, b, and the constant c, they are all integers. Previously, a was equal to 1 and therefore wasn't present. However, a is no longer 1. Here are the key concepts for today's lesson. You should always look for a common factor before you use today's technique. And I'm going to be explaining today's technique with examples. You can always look at this on your own. In our first example, we want to factor this quadratic expression. I want you to take a look at the numbers. You'll see that the coefficient of x squared is no longer 1, it is 3. As well, we want to see if we can factor anything out of these three terms before we begin. 3x squared plus 8x plus 4. Is there a greatest common factor of 3, 8, and 4? No, because the greatest common factor would be 1, and dividing out 1 does nothing. Is there a variable common between these three terms? The answer is no. Therefore, we need to factor this using a different technique. I want you to take a close look at the coefficients of 3, 8, and the constant 4. We want to think of two numbers when multiplied together will give me the product of positive 3 and positive 4. If you go ahead and do the mental math, the product of positive 3 and positive 4 is positive 12. We also want to think of two numbers when added together will give me positive 8. Where did I get these numbers from? I got these numbers from the coefficients as well as the constant. At this point, you'll need to use your times tables as well as some guess and check. And the two numbers that multiply to give me positive 12 are positive 2 and positive 6. And if you add up those same two numbers, you should get positive 8. What we're going to do now is we're going to decompose the middle term. What exactly does this mean? Well, this means that we're going to break apart this plus 8x. Decompose means to break down. So I'm going to write 3x squared. I'm going to break this plus 8x down into plus 2x and plus 6x. The plus 4 stays the same. Where am I getting these numbers from? Well, we figured that earlier. So what we're going to do now is you're going to do a little bit of group factoring. You're going to separate these two terms from these two terms, and then you're going to find a common factor for these two groupings. Let's go ahead and do that. If you look at these first two terms, you'll see that there is no greatest common factor of 3 and 2 because it's 1, but there is a common variable. That common variable is x. Therefore, I'm going to factor out an x, so that would become just 3x, and that would just become 2. Again, if you wanted to check your work, you can just use a distributive property. I'm going to do the exact same thing with the second grouping. I have the numbers of 6 and 4. The greatest common factor of 6 and 4 is 2. And that leaves me with 3x plus 2 within the brackets. Again, you can use the distributive property to check your work. If you've done this properly, you should be able to factor out a binomial. And that is the binomial you should be able to factor out. Therefore, I'm going to write bracket 3x plus 2 and x plus 2 in brackets. Therefore, if you want to factor this quadratic expression, the answer would be 3x plus 2 multiplied by x plus 2. In our second example, we want to factor this quadratic expression. We're going to use the same technique as our previous question. You should first realize that the coefficient of x squared is not 1. It is 3. Therefore, you need to use the technique that we've been using today. Let's start by rewriting our question. 3x squared plus 2x plus 4. Let's take a look at all of these three terms. What is the greatest common factor of 3, 2, and 4? Well, the greatest common factor of those numbers is 1, and that doesn't really do anything if we factor out a 1. Again, we want to take a look at the three terms and see if there's a variable common between all of them, and there is no variable common between all of them. Therefore, I want you to take a close look at the coefficient of 3, the coefficient of 2, and the constant of 4. You want to think of two numbers when multiplied together will give you the product of positive 3 and positive 4. And that is positive 12. Again, you want to think of the same two numbers when added together will give you positive 2. You're going to be using some times table and mental math at this point, and you should be able to determine that there are no numbers that satisfy both of these two equations. Therefore, you can conclude that this quadratic expression is not factorable over the integers. So I'm going to write a little note. Not factorable over the integers, meaning you can factor this, but you'd probably come up with some sort of number with a decimal. In our third example, we want to factor this quadratic expression. Before we begin, you want to notice that the coefficient of x squared is not 1, it is 6. Let's begin by rewriting our question. 6x squared minus 5x plus 1. Take a look at 6, 5, and 1. What is the greatest common factor of these numbers? Well, the greatest common factor is 1, and that doesn't really help us. Also, we want to see if there are any common variables within these three terms, and there are no common variables between all of these three terms. Therefore, I want you to take a close look at this coefficient of 6, this coefficient of negative 5, and this constant of positive 1. You want to think of two numbers when multiplied together will give you the product of positive 6 and positive 1. Positive 6 times positive 1 is positive 6. Again, you want to think of the same two numbers when added together will give you negative 5. At this point, you need to use your times tables as well as some guess and check, and you should come up with the two integers of negative 2 and negative 3. Because negative 2 times negative 3 gives you positive 6, and negative 2 plus negative 3 gives you negative 5. At this point, we want to decompose the center term, meaning we want to break it down. So everything else stays the same except for that negative 5x. I'm going to break it down into negative 2x and negative 3x. Plus 1 stays the same. At this point, you want to group these terms and do some group factoring. I want you to take a close look at the first grouping of terms. We have a 6 and a 2. What is the greatest common factor of 6 and 2? Well, that is a 2. As well, what variable do they have in common? The variable they have in common is x, and the lowest exponent is 1, but I'm not going to write that exponent in. That's going to leave me 3x minus 1. You can divide out 2x from these two terms on your own. I've just skipped a step. Remember, you can always use the distributive property to check your work. Now let's take a look at the second grouping of terms. We have a 3 and we have a 1. What is the greatest common factor of 3 and 1? Well, that is 1. That doesn't really help us. More on that later. Take a look at the variables. There are no variables common between these two terms. Therefore, we can't factor out a variable. So let's go back to this 1. let's factor out a negative 1. If you factor out a negative 1, this becomes positive 3x, and this becomes negative 1. Remember, ultimately, you want these two binomials to be exactly the same. If you do not factor out a negative 1, for example, let's say you factor out a positive 1, those two binomials would not be the same. So this is a little bit tricky, and you have to play around with the signs sometimes. At this point, we're just going to factor out a binomial because that binomial is common. So 3x minus 1 gets factored out, and your 2x minus 1 is at the very end. Therefore, this quadratic expression factored is 3x minus 1 multiplied by 2x minus 1. In our fourth example, we want to factor this quadratic expression. Again, you'll notice that the coefficient of x squared is not 1, it is 10. As well, you'll notice that there are two different variables present. There is an x and there's a y present, something that we haven't seen before. Let's begin by rewriting the question. If you take a close look at all of the three terms, you'll see that we have the numbers 10, 3, and 4. The greatest common factor of 10, 3, and 4 is 1. So there's no point factoring out that 1. As well, there is no common variable between all three terms. And therefore, we're going to have to use the technique that we've been using today. So I want you to take a look at the numbers that are present, 10, negative 3, and negative 4. You need to come up with two numbers when multiplied together will give you the product of 10, positive 10, and negative 4. Positive 10 multiplied by negative 4 is negative 40. Again, you want to think of two numbers when added together will give you negative 3. If you use your times tables as well as some guess and check, you should come up with the two numbers of negative 8 and positive 5. Negative 8 and positive 5. So negative 8 times positive 5 gives you negative 40, and negative 8 plus positive 5 gives you negative 3. We want to decompose this center term with the numbers we've just found. So everything else stays the same. That's going to decompose to negative 8xy and positive 5xy, and the negative 4y squared stays the same. At this point, we're going to need to do some group factoring. So I want you to group those two terms together as well as those two terms together. If you look at the first grouping, we have a 10 and an 8. The greatest common factor of 10 and 8 is 2. Again, the common variable between these two terms is x, and the lowest exponent is 1. However, I am not going to write that in. Therefore, you can divide each of these terms by 2x. So this is going to become 5, that is going to become an x, and this is going to become a negative 4, and that y is going to stay the same. Again, you can always double check your work by using the distributive property. If you take a look at the second grouping of terms, you'll see the numbers 5 and 4. The greatest common factor of 5 and 4 is 1. We're not going to write that 1 as a factor unless we need to. The common variable here is y. So I'm going to factor out that y, which leaves me 5x minus 4y. Again, your goal is to get these two binomials exactly the same, which we have done. Therefore, we can factor out this binomial, 5x minus 4y, which leaves us 2x plus y. Therefore, we've just factored this quadratic expression, and we've discovered it to be 5x minus 4y multiplied by 2x plus y. Before we start our last example, I just want to clarify that there's a little bit of a typo here, and this question should actually read 16x squared plus 26x subtract 12. Now that I've corrected this typo, let's begin this question. I want you to take a look at all three terms. specifically the numbers 16, 26, and 12, you need to ask yourself, what is the greatest common factor of these three numbers? Well, the greatest common factor is 2. As well, we want to see if there's any variables common between all of these three terms. There is no variable common between these three terms, therefore let's just factor out a 2. When we're factoring out a 2, all we're doing is dividing everything by 2. That becomes 8x squared, that becomes 13x, and this becomes negative 6. At this point, you want to take a close look at all of these three numbers, 8, 13, and negative 6. You want to find two numbers when multiplied together will give you the product of positive 8 and negative 6. Positive 8 multiplied by negative 6 is negative 48. As well, you want to find two numbers when added together will give you positive 13. We're going to use some mental math as well as your timetables and guess and check to figure out these two numbers to be positive 16 and negative 3. And when you add up those same two numbers, you will get positive 13. Therefore, we want to decompose this center term. Everything else stays the same. So that 2 stays exactly the same. I'm going to change this plus 13x into plus 16x and negative 3x. We're going to have to do some group factoring. I want you to take a close look at those two terms as well as those two terms. This 2 is going to stay the same. Let's just make these brackets a little bit bigger. What is the greatest common factor of 8 and 16? That is going to be 8. I want you to take a look and to see if there are any common variables between these two terms, and a common variable is x. The smallest exponent is 1, but I'm not going to write that in. At this point, you're just going to divide everything by 8x. So that is going to become x, and this is just going to become 2. We're going to repeat the process for the grouping of terms on the right. So I want you to find the greatest common factor of 3 and 6, and that is going to be 3. However, I actually want to factor out a negative 3, and you'll see why in a second. Are there any variables that are common between these two terms? The answer is no. So let's just divide everything by negative 3. That will give us x and positive 2. If you did not factor out this negative 3, you would not get identical binomials, which is what you want. So if you factored out a positive 3, you'd have to play around with the signs to get the same binomial. That might take some time. Anyways, at this point, you want to factor out the binomial that is common here, and that is x plus 2. That's going to leave me 8x minus 3. We can close the brackets. You should realize at this point that those outer brackets are completely unnecessary, and I'm just going to simplify this to 2 multiplied by x plus 2 multiplied by 8x minus 3. And we've just factored our quadratic expression